event before lunch is the series of lightning talks. So I think we have two of the Data Science Initiative fellows here. Any chance I could ask you to come down to the front so we can line up and run like lightning? Quick background on what's going on with this. Harvard has a new data science initiative that has launched this year, and has all sorts of stuff going on campus, new degree programs, a team of fellows of whom we have 2 representatives, right, and we have computing to set up as well, and all sorts of infrastructure and events and so forth on campus. The CMSA is very excited to have more people here thinking about data science and big data. And we thought this was a good opportunity to introduce a couple of the fellows to all of you and to the more broader community here at Harvard. So I think you both have like lightning slide decks, right? So we're going to do brief lightning talks. This will be, format is 5 minutes each, and then we'll retire to lunch, and you grill them with questions and all sorts of exciting ideas. And a few moments while we, like lightning, set up the slides. Hello?
This is about a new kind of shrinkage for non-parametric model selection. The idea itself is very simple. This is situation, this is data. This is a simple just regression setting. And we have covariate X, and we have response data Y. Then we would have this model. This is a regression model. Actually, the Gaussian error is not an issue, and you can put any heavy-tailed the distribution for the error. But our main concern is to estimate F. In this data set, the natural choice is linear regression because we can see that it has an obvious linear pattern. Then what about this data set? This data set is not linear. Then we might consider some non-parametric regression model like that, like spline's Gaussian process and or kernel methods. This is simple. This is not a challenging problem because we can use goodness of fit test first to choose a model, like a linear model or a non-linear model. And we can draw a scatter plot to see if it's a linear shape or not. But if the function is not one-dimensional, like multi-dimensional situation, or we have to estimate multiple functions, then using goodness of fit test is not straightforward, and scatter plots are not available when the dimension is higher than 3. Okay. Instead, the idea is let's use a shrinkage approach. The main idea is that I'm going to consider this semi-norm. F is n by 1, the regression function of vector. Then I minus P naught. P naught is the projection matrix of parametric basis functions. In the previous example, we are interested in that the regression function is linear or not. Then the parametric basis function is going to be the vectors of 1 and x. Then interesting fact is that this semi-norm is 0 if and only if the F is the pre-specified parametric shape. In this case, a linear shape. Then the idea is to force this semi-norm shrink towards 0, then put a sparsity penalty in a frequentist perspective or a shrinkage prior in a Bayesian perspective. Okay. So you have any question? No? Okay. That's the main idea. Then the resulting estimator of F shrinks towards the parametric function if the data supports the parametric, otherwise it keeps the non-parametric shape. And this idea is used in my paper, Functional Horseshoe Priors for Subspace Shrinkage. If you're interested in this idea, then you can read my paper. It's archived. Thank you. Simple.